Hello, myself Sachin Gaware from RBNB College, Shrampur. In today's lecture, we continue our chapter L.P.P, that is Linear Programming Problem from 12th Science paper first. Now, in this lecture, we start exercise 6.2, in which we have to find the feasible solution of an given inequalities by graphical method. Feasible solution means a solution set or a convex set which satisfies all the given inequalities. Now here first we observe that in all these cases, here it is x is greater than or equals to 0, y is greater than or equals to 0, x is greater than or equals to 0. Means remember one thing, whenever we have given x is greater than or equals to 0 or y is greater than or equals to 0, it means we consider the first quadrant only. And these two inequalities are also called as non-negative constraints or non-negative conditions. So now first we take the first example, that is number 1. Now in problem number 1, we have the given inequations are 2x plus 3y is less than or equals to 6. Next is x plus y is greater than or equals to 2, and next one is the non-negative constraints or inequation, that is x is greater than or equals to 0 and y is greater than or equals to 0. Now to find the feasible solution for these inequations, first we plot a graph. Now to plot a graph, first we convert these inequations into an equation of line. So for that we write a table in which we shows a line. Then to plot this line, we have to find the 2 points. To find 2 points, we put first x equals to 0 and then y equals to 0. Now converting this first inequation into a equation, or we can say in the line, it can be written as 2x plus 3y equals to 6. This is the first line. And second one is x plus y equals to 2. X plus y equals to 2. Now in this first equation, if we put x equals to 0, we get 3y equals to 6. When we put x equals to 0, we get 3y equals to 6, which gives y equals to 2. So the first point we get, that is 0, 2. Now in same first equation, now we put y equals to 0. Now whenever we put y equals to 0, the remaining equation is only 2x equals to 6, and which gives x equals to 3. So the next point is 3, 0. Now similarly, if we put x equals to 0 in second equation, we get y equals to 2, and when we put y equals to 0, we get x equals to 2. We get x equals to 2. Now we draw these lines on graph. So to draw these lines on a graph, these are the coordinate axes. These are the coordinate axes, and here we take the appropriate measure or units. So here we take 1, 2, 3, and on y-axis it is 1, 2, 3. Here it is -1, -2, again here -1, -2, here it is the origin. This is the x-axis and y-axis. Now for the first line, the first point is 0, 2. 0, 2 means it is on y-axis here. And the second point is the 3, 0. Here it is the 3, 0. So connecting these two lines, 2 points, we get the first line. We get the first line whose equation is 2x plus 3y equals to 6. Now similarly we plot the second line for the points 0, 2 and 2, 0. Again 0, 2 is here and 2, 0 is here. So again we connect these two lines. We connect these two points, and by connecting these 2 points we get the second line. Now after plotting these lines on a graph, now we consider the inequalities. Now here the first inequality is of the type less than or equals to. And we know that whenever the inequation or inequality is of the less than or equals to type, we consider the region below that line. So now we have to consider the region below the first line. Now below the first line means indirectly we have to consider all these region which is shaded by the which is denoted by the yellow color. Now again in second equation is of the type greater than or equals to, and we know that whenever the inequation is of the type greater than or equals to, we consider a region above the line. So when we consider the second line, we consider this region which is denoted by the blue color. Now observe here, that is the region which satisfies both the conditions. That is the region which is the below the first line and above the second line is only this triangle. This is the only this triangle. So this is the feasible region. So we do not consider the remaining region, because the remaining part of the graph is either satisfy the first condition or the second condition, or may do not satisfy any condition. So here this is the triangle. Let me give the names of the corner. That is, suppose A, here it is B, and suppose this is the C. So the region, bounded region A, B, C, A, which is which region? The bounded region. Region A, B, C and A. This region which is shaded by the blue color is the feasible region. Feasible region means a region which satisfies all given inequalities. So thus the region A, B, C, A is the solution for these inequalities. Now we see the next problem. In which the given inequalities are, now the second problem, 3x plus 4y is greater than or equals to 12. Second equation is 4x plus 7y. 4x plus 7y is less than or equals to 28. Next is y is greater than or equals to 1, and next one is x is greater than or equals to 0. Now we have to find the feasible region or the common solution for these inequalities. Now to find the common solution, again we make a table. In which we convert these inequations into equation, that is the equation of line. Then we put x equals to 0 and next y equals to 0. Now the first line becomes 3x plus 4y equals to 12. 3x plus 4y equals to 12. The next line is 4x plus 7y equals to 28. And the last third line is y equals to 1. Is y equals to 1. Now, in first line, suppose we put x equals to 0. Now, when we put x equals to 0, we get 4y equals to 12. We get 4y equals to 12. And which gives y equals to 3. Which gives y equals to 3. Now, when we put y equals to 0, we get 3x equals to 12, which gives x equals to 4. So, we get the next point, that is 4, 0. Now, in second equation, similarly, when we put x equals to 0, we get 7y equals to 28. So, which gives y equals to 4. Y equals to 4. And when we put y equals to 0, we get 4x equals to 28, that is x equals to 7. That is x equals to 7. So, we get the next point, that is 7, 0. Now, here only it is the y equals to 1. So, this is the line directly passes through y equals to 1. So, here it is not given any points. Okay. Now, here we plot the graph for these inequations. Now, we plot the graphs for these inequations. Now, this is x-axis, y-axis. And we take the points. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Now, for the first line, the points are 0, 3 and 4, 0. Now, here, this is the point 0, 3. And next point is 4, 0. This is the 4, 0. Now, by connecting these 2 points, we draw a line. We draw a first line. Now, this is the first line. Similarly, for the second line, the points are 0, 4 and 7, 0. So, 0, 4 and 7, 0. These are the 2 points. So, similarly, we connect these 2 lines, 2 points. We connect these 2 points. And now, for the third, that is y equals to 1. This is the line y equals to 1, which is passes through the point y equals to 1. So, this is the y equals to 1. This is our second line and this is our third line. Now, observe the inequations. Now, the first inequation is of the type greater than or equals to. This inequation is of the type greater than or equals to. So, we have to consider the region above the first line. Now, that is above the first line means this relation, this region. This is the region which is above the first line. Okay. Now, for the second inequation, now the second inequation is of the type less than or equals to. And we know that for the less than or equals to, we consider a region which is below the line. Again, this is the region, that is the second inequation which is of the type less than or equals to. This is the region. And for the third again, now in third inequation, y is greater than or equals to 0, that is above the third line. Now above the third line is, this is the region. So if we observe here, the common region which satisfy each inequations is the region, that is, which is the above the first line, below the second line, and again above the first line. So this is the region which satisfies all the inequations. So this is called as feasible region. This is the feasible region. We give the names for the corner, that is A, B, C and D. So here the feasible region, or we say that the solution of the given inequations are the bounded region A, B, C, D, A. A, B, C, D, A again. This is the solution for the inequations. Feasible solution. Feasible solution means again it is the region which satisfies all the given inequations or given inequalities. Now we go for the third example. Now in third example, we have given the combined now we see the third example. In this third example, we have given the combined inequalities. That is, here we have given the inequalities 0 is less than or equals to x is less than or equals to 3. Next is 0 is less than or equals to y is less than or equals to 3. And last one is x. Next one is x plus y is less than or equals to 5. And next one is 2x plus y. 2x plus y is greater than or equals to 4. Is greater than or equals to 4. Now, here first these two inequations or these two inequalities are combined. That is, if we consider the first part, that is x is greater than or equals to 0, that is the first quadrant. Here also it is y is greater than or equals to 0. So in these first two inequalities, we consider only the second parts of these inequalities, because the first part shows the first quadrant only. So to draw or to find the feasible region or solution, here again we make a table which shows line, then x equals to 0 and y equals to 0. Now here first line becomes x equals to 3, next becomes y equals to 3. Now next is x plus y equals to 5, and last one is 2x plus y equals to 4. Now for these first two inequalities, we directly draw the line. So now for the third one, x plus y equals to 5, we put x equals to 0, so which gives y equals to 5, and when we put y equals to 0, we get x equals to 5. Similarly again, if we put x equals to 0, we get y equals to 4, and if we put y equals to 0, we get 2x equals to 4. 2x equals to 4, which gives x equals to 2 only. Now we plot this graph. So here, now first we draw the quadrant. This is x-axis, this is y-axis. Now take a points. Now here let it is 1, 2, 3, 4 and 5. Also here 1, 2, 3, 4 and 5. Now the first line is x equals to 3 and second is y equals to 3. Now this is the line x equals to 3. That is the line passing through x equals to 3. This is the first line. Similarly, the second line, that is y equals to 3. This is the second line, y equals to 3. Now, for the third line, the points are 0, 5 and 5, 0. This is the 0, 5 and 5, 0. So, this is the line. This is the third line. This is the third line. And next line is passing through 0, 4 and 2, 0. This is the 0, 4 and this is 2, 0. So by connecting these 2 points, this is our fourth line. This is our fourth line. Now we have to find the common region. So now for x is less than or equals to 3 and y is less than or equals to 3, the region is below the y is less than 3 and left side of x is less than or equals to 3. These are the regions. Now for the third is x plus y is less than or equals to 5. Again for the x is less than or equals to 5, that is below this line, third line. And now fourth, 2x plus y, that is the fourth line is greater than or equals to, so above the fourth line, so this is the region. So if we observe here, this is the common region. This is the common region which satisfies all the inequalities, and therefore this is the solution for the given inequations, or we say that this is the feasible region. So again we give the names A, B, C, D and E. So the bounded region A, B, C, D, E and A is the solution for the given inequations, Here we will stop. In next lecture we start the LPP, that is linear programming problems. Thank you.